Primary control traverse for field engineers. Construction survey control basics. In this video, I'm going to talk to you about how traversing really ties into how we should be setting up a project as a field engineer. And I'm going to draw it the way I understand it. And I'm going to encourage you to check out the book Construction Surveying and Layout by Wes Crawford if you want to know more. And we have some pretty cool videos on the Lean Survey channel. So all kinds of good stuff here, but let me talk about this. When you have a building in construction and you want to properly control it. See, the term control, and I'm not talking about toxic like abusive spouse control, but like control. We're trying to control the where of every component on the project site. So control is like we're keeping control of that building, right? So if we want to lay out the foundations and the slab on grade and then start going up for this building, we need to get there from the basis of bearings. So typically we'll have, like let's say out here on the road, there's a city monument, and then over here on the road, there's another city monument, and they're like, hey, go build this building. Okay, great. Well, you're gonna have to go research with the surveyor or with the civil engineer, the northing, easting, and elevation for these monuments, and make sure that these are the ones that were used in the design. See, now let me make sure I'm doing a good job here. Whatever basis of bearings and design benchmark is what I call it, it's basically a city monument with an elevation, was used to as-built the elevations and the topography on the site to design the building is what you now need to use to lay out the building, at least to double check it. So if I want to build this building and I'm like, hey, I want some primary control around the site in concrete monuments that are permanent, that will control the building, right? I will make sure that it is surrounding the building and the entire project site, and I will make sure that it ties to the basis of bearings. So what I would do is I would connect a traverse from here to here to here to here, 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 here. Let's go that direction and then back. And what a traverse basically is, and let me just do it with 3 points. When you do traversing, you set up your total station and you shoot a distance, then you turn an angle, direct, reverse at a minimum, and then you shoot a distance. Then, depending on which direction you're going, you'll set up again and you will shoot a distance, and you'll do direct, reverse, and then shoot another distance, so you have 2. Then you'll set up over here, and you'll shoot a forward distance, so you have 2, direct, reverse, shoot another distance. So now every leg has 2 distances, and it has direct and reverse shots for the angle. And what happens is those numbers should create a perfect geometrical object, but they won't because of human and instrumental error. So this is what I like to do when I'm teaching field engineers. That triangle, yep, I got it right here, I think. Yep, perfect. Like that triangle should hit flat, but because of human and instrumental error, once you move the measurements into AutoCAD, it will have a gap. And that is called your linear error of closure. So what it does is if you're within the right accuracy, it will close and adjust the data so you have accurate coordinates at all of the different points. So traversing is essentially networking these points together in a precise way. Accuracy is, am I in the right location per the world, right? Precision is, do I have a good relationship from point to point within a network. So precision and accuracy are 2 different things. So when I do this, I will network these points together. And here's a really important point. If these points already have survey coordinates, you can plug those into AutoCAD, but I'm just going to do a little bit of a sketch over here. Let's say that that's your points, and in AutoCAD you plugged them in from the survey data. And then you go do this traverse and you're like, oh my gosh, we closed with greater than 1 in 50,000, which is what I typically recommend, which means that you did such good work on this traverse that it would take you 50,000 linear feet of traversing to be off a foot. That is the ratio that they use to make sure that you have an accurate traverse. So let's say that you're above 1 in 50,000, you're like, oh, my points are good. That's the biggest mistake people make. Just because you did a good traverse doesn't mean you know these points are right. What you have to do, I hope you like and subscribe. But what you have to do then is take your traverse coordinates and overlay them using your basis of bearings as your basis, and then overlay it over the points. And I'm just doing a little demonstration here. Let's say the black marks on this sheet were the coordinates that you got from the surveyor, and the blue is what your traverse came up with. Well, obviously you can see you're pretty close on these, but this one's way out of whack, and we find this all the time. And so the traverse has to be overlaid with the survey coordinates, and that's why we go back to that other video, that it's important to do that in AutoCAD or Civil 3D to make sure they're correct. Now, if you see this problem, you call the surveyor back out and you reconcile it, and then you align and make sure that everything's pretty close. The other thing you can see is if you're within acceptable tolerances. Like if this is 0.01 off, 0.01, 0.01, 0.015, 0.02, 0.02, 0.025, and this one's 0.05, and this one's off like by 0.80, you're probably going to want to adjust that one too and talk to the surveyor about that one. But the traverse points are very crucial to get the network tied in the way it needs to be. And let me tell you why. If you just take these random, I'm going to call them random because typically surveyors will just go spray points with a 4-foot prism pole and it's garbage. They will not be accurate. If you go take these points and you like set up over here and you're like, hey, I want to lay out the baseline for this building, and you set up backside farther backside than foresight, and you lay out these 2 points, and then you set up over here and you backside a backside that's longer than this building, longer backsides than foresights, and you lay out these 2 points, and let's say you do it from a third point, which is typically a good practice, and you actually look in here at this monument, and I'm just going to draw this real size. This is what we see. You'll see a point here. You'll see something like that. You're like, what in the world is that? What's the real point? You're introducing a lot of error, and you are also not maintaining consistency. Once you get the surveyor and you align and you use the coordinates from your traverse and you lay out this endpoint of the baseline from one side, having a longer backside than foresight, and then from this side, and then from this side, and you actually go zoom in to one of these, and I'm telling you, this happens every time, you'll see exactly what I just drew right there. 3 perfect little dots, and the real point is right in the middle, taking the average of that, and that's getting rid of that instrumental error. And so that 3/16 of problem inside the total station, that's going to get rid of it. So you can literally position any building within this network whenever you want, as long as you've done this right. Now, a couple of rules. When you do the traverse, I want you to use, for backsides, I want you to use tribrax with the prisms. This is spelled differently depending on what survey shop you're using. Don't get mad at me. I also want you to have greater than a 3-second gun. I also want you to do forward and back and direct and reverse shots. I also need you to close the traverse, and I need you to do the traverse computations to get rid of the error, and then I need you to compare the traverse with the actual points. And if you do that, this is what you're going to do. You are going to end up with beautiful, tied in, aligned to the basis of bearings, beautifully accurate, beautifully precise points from which you can go lay out your secondary baselines and anything else, where if you hit them from 3, or any layout that you're doing from 3 sides of a traverse, you'll get a perfect little triangular pattern, and you'll be able to take the average and have the exact right point. And this matters because if you're like on big airports, if you don't have that, if you don't do it from different sides of a traverse, you'll have this building over in this direction, that one over in that direction, and then when you connect them with bridges or other connections, it won't be accurate. So you've got to be able to do this. Traversing is great. The next step is level loop. We'll cover that in a different video, but if you follow these practices with Wes Crawford's book, you'll be spot on. I wish you the best of luck. On we go.